All right, next section is 3.3, and everything that we did in sections 1 and 2 were based upon which operations? Addition and subtraction. And we'll remember, kind of in a nutshell, is section 3.1 talked about conceptual ways of thinking about addition. That's what it really did. So we had different models that we looked at. We talked about creating word problems that would be associated with those models, or pictures that were associated with models. We talked about the properties of addition, subtraction, for those. And then in section 2, we talked about algorithms for that, those methods of doing this, right? Processes, ways of computing, okay? We're going to do the same thing in 3.3 and 3.4. We're going to part in just that same way. So 3.3, we're going to talk about conceptually the ideas of whole number multiplication and division. And then when we get into 3.4, if I'm not mistaken, we're going to talk about them from an algorithmic point of view, okay? So we're back to talking about conceptual ways of thinking about multiplication and division. And the first thing we need to look at is what the definition is for multiplication. That shouldn't say addition. I think I fixed them all except for that one. So this should say multiplication. All right, so multiplication of whole numbers. So for every whole numbers a and b, and n is not equal to 0, then n times a is equal to a plus a bunch of these dots a, and there are n terms here. There are n a's. This is the first way we talk about our need for multiplication. If you wanted to add the number 3 together 15 times, you really don't want to count 3 equals 3 equals 3 equals 15 times. You don't want to do that, right? We would like a shortcut to doing so, and that shortcut is called multiplication. All right, so and the other issue is that if the n value actually equals 0, then we say that 0 times a, by definition, is 0. Okay, that's the definition that we create. And then we can also talk about this from a set theoretical point of view. So we did this with sets before. That if we have n of a plus n of b, and we want to talk about multiplying n of a times n of b, this is the same as a times b in the description here, then this is the same as multiplying the Cartesian product. So do you remember doing those Cartesian products? And we had this formula actually just like this in that section. Okay, so we can put them in ordered pairs, pair everything up. And once we paired everything up, we can count how many pairs of things we have. And once we did that, we found out the number of items in that set. Okay, so these are two different sort of alternate forms of thinking about multiplication. This kind of idea of repeated addition, or this idea of pairing things and counting how many pairs we have. And that's all well and good, but what I want to talk about is taking a look at the picture forms, the models of how to think about this. So the first one, repeated addition, harkens back to that actual description that I first gave you, right? This idea of adding something together a bunch of times, okay? So we're going to take an example, and I'm going to show you what I'm showing you in these is a picture form of each of these that we do. So it says Jessica takes 3 tests every Friday. After 4 Fridays, how many tests has she taken? Okay. Well, from a entry-level point of view on multiplication, she took 3 tests on the first Friday, and 3 tests on the second Friday, and 3 tests on the third Friday, and 3 tests on the fourth Friday, for a grand total of 12 tests. Okay, so this is the idea of multiplication represented as repeated addition. Okay, so I don't actually see pictures. You could see pictures on this, right, if there was an image that would be nice to talk about. So if I had 3 coins in my pocket and you have 3 coins in your pocket and you have 3 coins in your pocket, how many coins do we have all there? Can we draw coins? Sure. So if there's a picture point of view you want to draw for this, you can do that. On this one, there's just not really a visual picture that's just pulling at my heart right now. So I'm going to go with numbers, okay? The next one, though, we've got somebody making cookies, and we might be hungry before I'm done with the lesson, because that sounds really good. So we've got Marty, and Marty's making cookies. He's able to place dough 3 cookies wide and 6 cookies long in the pan. How many cookies will be on his pan? This one, I do have a picture for you that I can go with. So you guys are going to get yours drawn probably before I do, but it works really nicely to draw my cookies, right? And I need to draw the cookies. Where is it? It's been a clutter. I need to draw the cookies so that they're 3 wide, or long, either way. And I've got to have 6 of them across. All right, so here's 6 across. And on your paper, you're going to fill in the rest of them too. Okay, so we have this sort of an image. And there are different things in our society that make sense to count this way. I tried to give an example of one without giving the classic examples. But can you guys, well, in fact, I don't even want you to give them out loud because I'm going to ask you to do it on paper in a minute. You can think of things that are packaged this way, or organized this way, or created this way. And if I look at this picture, which is 6 long and 3 wide, or whatever, how many cookies do I have? 18. And could I count them? Sure, I could count them to find that. So there are 18 cookies. Now, what you'll notice is I've put in this description. Your book doesn't write it in like this, but I did. This is used for sets, okay? Because the other model is used when you don't have sets. It's more of a measurement perspective. So a measurement perspective in this case is going to be talking about things that could be divided. So if you take a look at this example, Alexis is planting a garden. She has space that is 5 feet wide and 7 feet long. How much area does she have to plant? Could I subdivide a foot? And it would make sense to talk about it in such a way. Yeah, it's sort of a measurement, whereas I don't measure the cookies, right? I'm just counting the number of cookies. So I may actually end up with cookies that are unequal in size in that first description, but that's not what I was doing. I was counting the cookies. So when you're taking a look at this perspective, you're thinking in terms of drawing a rectangle. It needs to be 5 by 7, right? So I'm supposed to have 5. I'll make them rows. Of course, they should look roughly equal. Mine aren't perfect, but yours won't be either. So, and then we need 7 columns. And I've got the picture that's not going to work. I think I can fix it. There we go. All right, so I have 5 here. And I have, I think, 7 here. And 5 times 7 is 35. And from a picture point of view, could you count the individual blocks? Sure. And you count them and you would get 35. And it's 35 what? Feet squared, or square feet, right? Because I multiply feet times feet, right? And so we could talk about at this juncture too, in working with multiplication, the area is always in terms of square units. Talk about how much space it covers, not how long the space actually is. All right, so this is the 3rd model for multiplication. So what I want you to do is, where you are, grab a partner, and I want you to come up with 3 examples, 1 for each of these. Okay? So let's see. Do we have the number of people here today? Almost. Okay, so Sean, why don't you join, I don't know, you're about to. Okay. All right, so go ahead and take a look then at getting some examples of these. 3 examples, 1 for each, okay? So grab your partner and create an example. No, you can do it on your desk, absolutely not. Okay, so let me give an example of repeated addition. Rachel, let's go first.
Okay, John runs 3 miles every Tuesday. After that, 20 miles.
Awesome, because I'm going to give another example of repeated addition. Yeah.
Bob eats 2 cups of food every day for a week.
Perfect. All right, how about array? Yeah, Beth. Jordan. I'm going to do it all year. Jordan, it's your turn.
Butch is grilling hot dogs. He has room for 2 hot dogs wide and 4 hot dogs long. How many hot dogs can he grill on?
Nice example. Good job. You guys have one in mind?
The Taylor residence hall elevator can hold 4 people wide and 3 people long. How many people total in that elevator?
Very good. Did anybody have any other creative things that are in arrays?
What?
Creative things that you could do with arrays.
We just need flowers.
Flowers? Okay, flower bed. Okay, what else? Cupcakes are good. How about hot hands? Hot hands. How about toilet paper rolls? You buy the toilet paper in the rolls like that? Yeah, it's got a volume issue to it too, when you ignore, but that kind of thing. All right, how about area? Who has a good area one? An area one.
We do.
Okay. Go for it.
Of course.
Cherish, your turn.
My mom is repainting my room. The wall is 14 feet tall and 23 feet long. How many feet does she paint?
How many square feet does she paint? Yes, and there's all
How
that.
many
square
I just
feet?
put how much does she paint?
You could say it that way and avoid the units altogether. Anybody else have another area one? Lauren?
Scott is tiling the bathroom. He needs 5 feet of tile wide and 6 feet long. How many square feet is he?
Perfect. All right. All right, let's